Hey Trig, these are the notes for section 8.3 part A. So this is going to be two videos for this section, and these are going to be, we're going to be using our calculator a lot for this section, and also your unit circle, so make sure you have that kind of ready to go. When we did stuff in section 8.2, we would have problems like, it would say like, evaluate inverse cosine of 0.6. Okay, so basically it would be kind of like writing example 1, but writing it in this way. So like x equals inverse cosine of 0.6. When they start it out looking like this, you are evaluating the inverse cosine. Okay, so you're trying to find that value of it. And I told you before that inverse cosine only exists in the first and second quadrant, okay, which is going to narrow your answers down so that you will only have one answer for that, okay. Now, when they present it to you like this, though, where you're actually finding cosine of whatever value gives you 0.6, this is a case where you will use inverse cosine to find the answer, but when they present it like this, they do want both of the solutions. So it's kind of like, how do we go backwards and find out what the other solution is when my calculator will only give me one of the answers, right? So you are going to use your calculator to do this. If we're solving for x, we're trying to get the x out of the cosines. So you end up doing inverse cosine of both sides, right? So x will be inverse cosine, just like I have written up above, of 0.6. And so basically what I'm trying to do is I'm trying to find where cosine is 0.6 at. Okay, now they didn't present it to me to start with as finding the inverse cosine, because then I would only have one answer. But now, since I'm finding cosine of that value, I have two solutions, okay? So we're going to start by finding just the first solution, and we just plug that into our calculator. So I do second cosine of 0.6, okay? And I get, and my calculator's in radians, so put your calculator in radians, because we do with these answers in radians. So one of the values I get is 0.9, let's say 0.93. We'll go two decimal places. 0.93, okay? But I know that there's another solution, and one way that I know this is because the graph of cosine, if you just think about the graph of cosine, he does one of these, right? Okay, and basically this is saying 0.6, this is up here at 1, this is down here at -1 on the graph. 0.6 is just going to be a little bit over half, so he's going to touch at 0.6 here, but he's also going to touch over there. Okay, so he does touch at two places, and that's basically what I'm solving for when I say cosine of x is 0.6. I want to find those places. So the first place that he touches right here is at an x coordinate of 0.93. But I also want to know this place right there. Where is that located at? Okay, and so to do that, I'm going to look kind of at my unit circle here. Okay, so when I'm looking at cosine, I do this in pencil so I can eventually erase it. When I'm looking at cosine, let's say I'm looking at pi over 3, okay, because cosine is 1/2 at pi over 3. So a really nice cosine value, 1/2, okay? He is also 1/2 at 5 pi over 3, or they write it as -pi over 3, okay? So he will have the same value at pi over 3 and at -pi over 3, okay? So I went ahead and I wrote that on here. And I labeled it down here like this. I said next to this box I put cosine of some value will be the same as cosine of that negative value, right? We said that cosine of pi over 3 will be the same as cosine of -pi over 3. Okay, that was kind of true in that case, okay? So what's going to happen here is, this one's very easy, because if one of the answers is 0.93, the other answer will be -0.93, okay, because I just do the negative of that value. Now, when we're looking at the graph of this, though, this value is obviously not -0.93. What they're doing, though, is they are picking on this point, not this one, they're picking on this point, okay? So this is 0.93, this is going to be a -0.93, and that's where he's going to touch a height of 0.6, okay? Now, one more thing that we have to do is this cosine function is going to continue on forever, so we need to add 2 pi n to it. I think we used n before. 2 pi n. Now we have to use 2 pi n because that's the period of cosine. So since this guy's going to go on forever, this point right here is actually the same as this point here, but just 2 pi later, or 2 pi after that, okay? This guy right here will be the same as this point right here because that's 2 pi later, okay? So we have those two as our two solutions, okay? All right, now sine, solving basic equations for sine. So we're going to end up finding both of the solutions, and we're trying to see where he touches negative 0.75. So we would again do the inverse sine to find the base, or inverse sine to find the first solution. So we would say x equals inverse sine of negative 0.75, and I want to find that on my calculator, and I'm still going to be in radians. So I'm going to do inverse sine of negative 0.75 or 0.75, and I get x equals negative 0.85 is what I'm going to get for my inverse sine. Okay, now, inverse sine is not going to be exactly the same as what cosine was, okay? The rule for sine is this. Let's look at for sine on the unit circle, okay? I'm going to pick on a really nice value of sine. Let's do pi over 6 because he's 1/2 again, so I don't have to look at the square root of 3's and all that good stuff. Okay, right here, sine is 1/2 at pi over 6. And then I'm looking at where is it also 1/2 at? Okay, well, it is 1/2 over here at 5 pi over 6. Okay, so then we have to determine what's the relationship between pi over 6 and 5 pi over 6. Because it's not like I'm adding half a circle to it, because that would be like down over here, right? Pi over 6 and 5 pi over 6, okay? The way that they are related is that 5 pi over 6 is equal to pi minus pi over 6, okay? So pi would be like 6 pi over 6 if I find a common denominator, minus pi over 6, that will give me 5 pi over 6, okay? So the rule here is, for sine, that when I have this value, okay, I take pi and I subtract that value, and that will give me my new coordinate, or my new answer, basically. Okay, so if it helps you to think about this in degrees to start with, okay, let's say 30 degrees and 150 degrees. Basically, you're taking 180 and you're subtracting 30 degrees to get that 150, and that gives you the second value, okay? So it might help you to think about it in terms of degrees rather than radians first, but that's the formula that you're going to use. Since we're in radians, we're going to do pi minus x, okay? So the first x that I got was negative 0.85, okay? So to figure out what that second answer will be, I will take pi and I will subtract a negative 0.85, okay, or pi plus 0.85, and that's going to give me a decimal, pi plus 0.85. That will give me my new answer of x equals 3.99. That's my other place where he's going to touch, okay? So that's going to be, I'm going to make sure I put plus 2 pi n and plus 2 pi n on each one of those because the period of sine is 2 pi. So that's going to be my two solutions, okay? So a little bit different than cosine, because cosine you just make the other one negative. This one you have to subtract it from pi in order to get your second value, okay? So that's kind of how that guy works, okay? Tangent then, still the same thing. We'll learn down here what the rule is for tangent. Tangent, I do inverse tangent. And x will be the inverse tangent of 3, okay? So to find my first value, the inverse tangent of 3, the first solution I get is 1.25, okay, 1.25. Now, I'm going to go ahead and put plus the period on the end of here, plus pi n. In this case, tangent's period is pi. So we change that to pi n instead of 2 pi n, like sine and cosine are. Okay, and then let's talk about the rule for tangent, okay? So let's see if we can figure out this one, okay? Tangent, I'm going to pick on 45 degrees because tangent here is really nice, okay? Tangent of 45 degrees is 1, okay? So where is also the other place where tangent is 1, okay? Tangent is 1 down here at 5 pi over 4, because this guy goes with that one. They're not really lined up very well. Or 225 degrees. So then I have to figure out what's the relationship between 45 and 225 degrees. Okay, well, they're exactly opposite the unit circle from one another. So the rule for tangent is that I am adding pi to the solution. So tangent of x is the same thing as tangent of pi plus x. Okay, that's where he will hit on the unit circle and hit those place values. Okay, so pi plus x. Sine was pi minus x and cosine was just negative. Okay, but tangent is pi plus x. Now here's the beautiful thing about tangent. Okay, what we need to do is, if we want to find the second solution, okay, I would really take 1.25 and add pi to that, right? Okay, but really, if I do that, we're already adding pi here. Okay, so I don't necessarily have to list my second solution here, because it's already kind of covered in this equation. Okay, so I don't have to list it twice. Good. Okay, I don't have to do that again. Okay, so tangent census period is pi, and you're adding pi n to him. You don't have to. I couldn't read it. I can't read it. I don't know, you're in bed. Probably not asleep. Layla's asleep, I know that for sure. Alright. Okay, so now let's go to the back side and let's see what else they have for us. Okay. So we'll do just a couple more of these on the back side, and then we'll stop for this video. So using solution algorithm, we want to solve 8 cosine x minus 1 equals 0. So I'm going to do the same thing as what I did before, except I just have to rearrange this equation and get cosine by itself. Okay, so what I'm going to do is I'm going to add the 1 over. So I have 8 cosine x equals 1, and then I would end up dividing by 8. So I have cosine of x equals 1 over 8. You might be able to do some of this in your head, and that's fine. Then I will do inverse cosine. Okay, inverse cosine. And x will be inverse cosine of 1 over 8. Okay. Second cosine of 1 over 8, still in radians in my calculator. So 1.45 is what I get for radians. Okay. Plus 2 pi n is what I need. Okay. And then we know that cosine also has another value, so we need to find out what that value is. And the rule for cosine, I need to set on the front side, is that cosine, whatever value you get, I would really suggest writing these down. Cosine, whatever value you get, will be the same as cosine of negative of that value. I think that's also maybe one of the identities in your unit circles. Yeah, right here. Opposite angle identities, right here. Cosine of negative a is the same thing as cosine of a. Okay, so that's kind of where that lives. Right, so that means that if we got 1.45 as an answer, another answer will be negative 1.45 plus 2 pi n. Okay, and that will cover all of the places where cosine is going to hit 1/8 that. Okay, so in the graph of my cosine, when he's doing, you know, like this type of thing, whatever, he's going to touch 1/8 here, 1/8 here, all the way across. These 2 points are going to be, well, this is this one, and this is this one, and then he's touching every 2 pi later. Okay, so that's kind of what that graph will look like. Okay. Next one, this one, we're going to use do without using a calculator. All right, so it's a solve sine of u equals the square root of 2 over 2 exactly without using a calculator. All right, so basically they're saying we still take the inverse sine, so u is going to be the inverse sine of the square root of 2 over 2. And the reason why they want us to do this without using a calculator is because I have a square root of 2 over 2 on my unit circle. Okay. So basically they're saying, where is sine the square root of 2 over 2? Okay, and so in this case, we're going to find the sine value, square root of 2 over 2. I see him first here at pi over 4, and then I see square root of 2 over 2 also at 3 pi over 4. Okay, now 5 pi over 4 does not work because it's negative square root of 2 over 2. Same thing over here. So both of them have to be positive, so I have pi over 4 and 3 pi over 4 are going to be my two solutions, okay? And in that case, so pi over 4, let's see, I'll write this down. U equals pi over 4, U equals 3 pi over 4, okay? I want to make sure I still put plus 2 pi n on each one, plus 2 pi n on that one, okay? And those are going to give me my two like sets of solutions, okay? Now, the rule for sine was that sine of x will be the same as sine of pi minus x, right? Okay, so let's just make sure that this fits into that, okay? Sine of pi over 4 is going to be the same as sine of pi minus pi over 4. Well, what do we get when we take pi minus pi over 4? This would be like 4 pi over 4 minus pi over 4. Well, that is 3 pi over 4, which is my other solution, right? So that's consistent with the, with the identity that I found, and that gives me my two solutions there. Okay, last one. We'll do this one and then we'll stop. It's a sine of 2x equals the square root of 2 over 2. Okay, so the only difference here is that we're still going to do the inverse sine. Okay. And then I'm going to do the 2 last because I have to get rid of the sine before I can get rid of the 2. The 2x are trapped together inside of the sine, so I have to get rid of the sine first. Okay, so here I would say 2x equals inverse sine of square root of 2 over 2. Okay, now I've already found out that inverse sine of square root of 2 over 2 gave me these two answers right here. Pi over 4 and 3 pi over 4, okay? So basically I have 2x is going to be equal to pi over 4, because that's what inverse sine of square root of 2 over 2 is, and 2x equals 3 pi over 4, okay? So I set the 2x equal to that, and then I just, to solve for x, I just divide by 2 for each one of those, okay? Divide by 2, okay? Pi over 4 divided by 2. If it helps you to think of it this way, you can do keep flip flip, and it would be pi over 4 times 1/2. So x is going to be pi over 8. Okay, and here I could do times 1/2 again. So x will be equal to 3 pi over 8. Okay, so same thing as what we were doing up above here, but you just set 2x equal to that instead of just x equals that, right? Okay, so that's how you'll just get rid of that last value. And then we need to make sure we still do plus 2 pi n on the end of each one of those. Okay, so don't deal with anything. If you ever kind of have a number inside of here that's not just x, deal with him very, very, very last. Okay, you get your answers and then you're going to find the value of that. Okay, so kind of confusing a little bit still. I know the people that the part that people struggle with the most is that in section 8.2. When it was presented to you this way, I told you you only have one solution because inverse sine only has one solution. That's when it's presented to you and they're saying find inverse cosine. But here we're trying to find cosine of some value, which means we do have to have two solutions. We're just going to be using inverse cosine to find those two solutions. Okay, so that's where people get tricked the most. Okay, if they present it to you this way, it's only going to be one solution. If they're presenting it to you as just cosine itself, you will have two. Okay, all right, we will do the last 3 or the last 4 problems in the next video.